Welcome back to the AI Research Roundup. I am your host, Alex. Alright, today we're looking at a fascinating paper from the Papers with Code trending list, published May 27th, 2025. It's titled Paper2Poster, Towards Multimodal Poster Automation from Scientific Papers. This work tackles turning lengthy research papers into concise posters. They've introduced Poster Agent, a new multi-agent system for this, and, significantly, the first benchmark to evaluate such tools. This benchmark uses a question answering format called Paper Quiz, and if you want to dive deeper, the code for this work is available on GitHub. So this repository offers the open source tools for their multi-agent poster generation system. You'll find the main poster agent, evaluation scripts, and instructions for turning research papers into editable PowerPoint posters. Okay, so this first figure, figure 1, really lays out the whole process. On the left, you see how a full scientific paper, noted here as being around 20,000 tokens, and tokens, by the way, are essentially small pieces of text, like words or even parts of words, that AI models use to process language, is fed into the poster agent system we just mentioned. This system then generates a poster. Then, on the right side, it shows the evaluation part. This is where the Paper2Poster framework comes in, evaluating a poster against its source paper, effectively answering how to assess the quality of that poster. Alright, so building on that evaluation framework we just saw, figure 3 here really unpacks the Paper2Poster evaluation process in more detail. On the left, it shows a kind of circular diagram outlining the different facets of evaluation. Things like aesthetic quality, information quality, and visual similarity. It also mentions using a vision language model, or VLM, as a judge. A vision language model is an AI that can process and understand both visual information, like images, and text. Then, the middle part illustrates how an LLM generates multiple choice questions from the paper, forming that paper quiz we talked about. And on the right, it shows how different vision language models, acting as diverse readers like a student or a professor, take this quiz based on the generated poster to measure its effectiveness. Okay, so we've seen how the Paper2Poster framework evaluates generated posters in figure 3. Now, figure 2 here gives us a closer look at the actual data characteristics this system is dealing with. Part A shows a word cloud, illustrating the wide range of research topics covered, with prominent terms like deep learning, computer vision, and neural networks. Then, parts B and C provide some really interesting statistics. Part B compares textual token counts, showing input papers in blue typically have many more tokens than the author-provided posters in red. And similarly, Part C shows the distribution of figure counts. Again, papers usually contain significantly more figures. These statistics really highlight that Paper2Poster is a multimodal context compression task. Alright, so we've seen the evaluation side with Paper2Poster and the kind of data poster agent handles. Now, figure 4 here zooms in on the poster agent pipeline itself, showing how it actually goes from a paper to a poster. It's a 3-step process. First, there's the parser module. This one takes the input paper and extracts key text and visual assets, essentially creating a library of important content. Then, the planner module steps in. It matches these assets and arranges them into coherent layouts, iteratively generating the different panels of the poster, even using a kind of zoom and operation for detail. Finally, the painter-commenter module does the rendering and provides feedback. The painter generates the actual panel content, like bullet points, while the commenter, which is a vision language model, checks for things like layout coherence and makes sure content doesn't overflow. Okay, so after seeing how Poster Agent works, Table 1 here really puts it to the test. This table shows a detailed evaluation comparing Poster Agent with other approaches, like end-to-end methods and other multi-agent systems, plus Oracle methods, which are essentially benchmarks like human-designed posters. They're judged on visual quality, text coherence, including perplexity, where lower scores mean more fluent text, and by a vision language model for aesthetics and information. The key takeaway is that poster agent variants perform very strongly, closely matching the human-designed poster quality, especially in the overall vision language model judge scores, which is a great result for their system. Alright, so Table 1 showed Poster Agent holding its own against human-designed posters in terms of quality. Figure 5 here gives us another important angle. It looks at how well these different poster types actually help convey information, using that paper quiz we talked about earlier. This plot shows the average density augmented score on the y-axis. The x-axis lists different vision language models acting as readers. We see lines for the original paper in blue, the human-made ground truth poster in red, another generated poster called 4.0 image in green, and Poster Agent Quinn in purple. Poster Agent QN consistently scores very well across these different vision language model readers, often matching or even exceeding the performance of the ground truth poster. This indicates that posters generated by Poster Agent are quite effective at communicating the paper's core information. So building on that visual from Figure 5, Table 2 here gives us a more granular look at those paper quiz results. It breaks down the performance of different models, like the original paper, the human-made ground truth poster, and the Poster Agent variants we've been discussing. The evaluation uses both raw accuracy, which measures how often the vision language model readers find correct answers, and those density augmented scores we saw earlier. And what's really striking is that the Poster Agent variants, particularly Poster Agent 4.0 and Poster Agent QN, achieve excellent overall density augmented scores. In fact, they're right up there with, and sometimes even exceed, the human-made ground truth posters. This really highlights their effectiveness. As we've seen, especially with those impressive paper quiz results in Table 2, the Paper2Poster approach, particularly with Poster Agent, really shines. It's not just about making nice-looking posters automatically. It's about creating tools that effectively communicate complex scientific information. This work could be a real game-changer for researchers looking to share their findings more broadly. Well, that's all the time we have for today's AI Research Roundup. Thanks for tuning in. I'm Alex.